This is problem 27 in chapter 2. And I'll read it quickly. A steel tank is to be positioned in an excavation determined by trigonometry A, the magnitude and direction of the smallest force P, for which the resultant R of the two forces applied at A is vertical, and the corresponding magnitude of R. All right, so let's sketch what we've got. What did I say? I think I said 27 is page 27, problem 13. I apologize if I misspoke. So basically we've got a hole that's been dug. They're calling it an excavation. Fancy word for hole. And there's a tank being positioned in it. Now there's a ring or a hook or something at the top with a 425 pound force at an angle of 30 degrees, and then a force P at some angle alpha. We're supposed to find the minimum amount of force. Okay. So here's the thing. Oh, and what else? And yeah, so for which the resultant, so the addition of these two, if we add them together, the resultant had better be a vertical force. So we're going to find the minimum force P for which the resultant is vertical. So let's think about this for a second. We have 2 degrees of freedom. We have the magnitude of the force P and the angle alpha we can select. How would you minimize force P? What would you do? It seems like the problem's wide open, right? It seems like we can choose a whole bunch of different options and they would work. Some would be more, some would be less. But how do we select the minimum? Well, let's discover something important about this. What do you know about the horizontal component of the 425 pound force? Could you find its magnitude? Yeah, that's just the base of the triangle, isn't it? Why don't we go do that? So let's see, 425 pounds. Do we want sine or cosine? Which side is this since it's touching the 30-degree angle? It's the cosine side. Remember, I abbreviate cosine as C. 30 degrees equals, and then cosine of 30 degrees, if I remember right, is a half, isn't it? Do the math for me if you would. It's either half or 0.866, I can't remember which one. But just tell me what.
0.866.
866, okay. So if you multiply that by 425, what do we get for our horizontal component of force? I guess I'll put it in there.
Uh, 368.
268 pounds.
368.
Oh, 368, thank you. Why did I calculate this force? Why would we care about the horizontal component of that 425 pound force?
Because that's what we need to cancel out. The vertical component is not what we're focusing on.
Exactly. If we're to have a vertical only resultant, whatever horizontal piece this has to be equal to that horizontal piece. So if I were to take the projection of force P, so let's call this P sub x, how would I calculate the magnitude of P sub x? P sub x would be equal to what?
What we need it to be?
No, how would we calculate, how would we represent the magnitude of P sub x in terms of P and alpha? Wouldn't it be P cosine alpha? Just like this is the magnitude of the force times the cosine of the 30-degree angle. Well, the magnitude of Px, this will do that, is just whatever P is times the cosine of alpha. Now can we answer the question, what's the minimum value of P? Well, think about it. If we want to minimize P, what will we have to do to this?
Minimize it.
Minimize it?
Well, if we're multiplying P by the cosine
So
of
we want
alpha,
P to be as small as, okay, this is fixed. Can't change this. This is a number. That number is that, right?
Okay.
Mhm.
So what do we have to do in order to minimize P?
Would you set it to 0?
Well, we want to maximize the what comes out of the cosine.
If
so
we
need
s-
it to-
Right. If we were to set this to 0, Px would be 0, right? So we can't do that. But what we gotta do, if we wanna minimize this, is maximize that. So we want cosine of alpha to be as big as possible. You're familiar with the cosine function, right? Where is cosine a maximum? In fact, what is the maximum you can get out of the cosine function? 1. Right? So at alpha equal to what do we get cosine equal to 1?
0 degrees.
0 degrees. Right? Because the cosine function looks like this. Put alpha there. Let's put cosine of alpha here. right there is the value of 1, and it does something like this. Well, I guess I draw a whole waveform. That'd be out at 2 pi. Okay, in radians, of course. So if we want to maximize cosine of alpha, we better set alpha equal to 0. So that cosine of alpha is equal to 1. Now think about what we just did. We made all of p that way. We did manage to minimize p, didn't we? That's going to be the minimum value of p, because now p will only offset the horizontal component. You were probably thinking, oh, it's probably going to be some angle in here because I want to add to that force. Well, if you give it some angle, the projection still has to be equal to 368, and all you're doing is adding to the force. You're sure you got more lifting force, but they asked us to minimize p, right? They didn't say choose p such that the tank will be lifted. You'll find that when there's a problem that's given, there's other ways to look at it. I like to explore those. So let's take care of this, and then we'll explore the idea, what if the tank weighs 800 pounds? Then what do we have to do? Okay. So let's start with the idea that we need to minimize p. In that case, alpha is equal to 1. So we've decided on something. Alpha is equal to 0. 0 degrees, 0 radians, whatever you like. It'll be the same number. Convert that to degrees if you like. It's trivial, right? And then calculate p sub x. Well, p sub x is 368 now. Okay, so there we go. 368 pounds is the amount of force we need, minimum, in order for this tank to be in static equilibrium. Because all we have to do is counteract the horizontal effect, excuse me, of the 423 pound load. Okay. All right, so that's the smallest force for which the resultant is vertical. Let me ask you another question. What is R? Well, there it is. How would we calculate the magnitude of R? What would we do then?
We would use sine on the force there.
Good. What you've noticed is that's the vertical leg of the triangle, right?
Yeah.
We're basically just playing with the right triangle. That's all we're really doing. And so you're right. We take 425 pounds and multiply it by the sine of 30 degrees. Now that I think is a half, isn't it? Okay, so we get what? 212.5 pounds, if I'm thinking right? Okay. So there's the vertical force on the tank. What if the tank weighs 800 pounds? Then what? What if we need to lift the tank? Well, we need the resultant to be equal to 800 pounds. That's a different question than minimizing p. P could not be 368 pounds in that case because we need to lift the tank, right? But we do know that px has to be 368 pounds. Why? Because we always have to offset the horizontal component of the force, you see, or the applied force. So could we calculate what R would have to be? Well, if we want to lift it, the resultant had better be 800 pounds, right? So this is a totally different problem. So let's change this a little bit. So let's separate this off. Let's just play with it and say, what if weight is 800 pounds? Now, what do we need to do with P? Well, notice Px, like I said, is still 368 pounds, isn't it? That hasn't changed. And we know now that the resultant had better be 800 pounds, but of course the resultant is equal to Py plus the applied force, let's see, 212.5 pounds. I hate plugging in numbers. In fact, let me do this instead. Let me say this is Ry, because this would not be R. The resultant had better be 800 pounds in that case. Well, I guess that was from the last problem, but Ry and R are the same thing in that case. Ry would still have to be the same. The total R would have to be 800 pounds plus, or 800 pounds, which would be Py plus Ry. Okay. So all we really have to do is solve for Py. Py then would have to be equal to 800 pounds minus whatever Ry is already contributing. We've already got a little bit of help here. We've got 212.5 pounds of help. So this is 800 pounds minus 212.5 pounds. Okay, so when we do the math, that's going to be what? 587.5 pounds, if I'm thinking right? Did I do that right? I think so, yeah. So PY would have to be 587.5 pounds. What does that tell us about P? Well, notice now we can say that P, let's see, let me do it this way. So PY is 575 pounds. Let me stick with black for P. R is 800 pounds, so let me make R decent size. So there's R, 800 pounds. We've already got a contribution. I wish I had a different color. Oh well. We've already got a contribution from the externally applied load, and all we've really done is said that PY must be that big. You see it? Where that big is 587.5 pounds, and the vertical component, the 425 pound force, was 212.5 pounds. Because those two together will counteract the weight, which is 800 pounds. Okay? Now notice this completely defines P, because think about it, what we could do is, in order to calculate P, or to understand P better, we could take this vector and this vector and put them together. In other words, let's pull them off to the side, draw PY here, which is 587.5 pounds. Draw PX here, which is 368 pounds. And P itself then would be that vector. But what would its magnitude be? How much force are we talking? Well, it's just a triangle again. So all we have to do is say P equals the square root, 587.5 squared plus 368 squared. Of course, both are pounds, so we'd end up with a number. What's the number, by the way? So take 368 squared plus 587.5 squared, and take the square root. What do we have?
693.
693?
Yeah, 0.2.
Okay. 693.2 pounds. That's fine. Now, this is a different problem than what was asked, but it is an interesting question, isn't it? So 693.2 pounds. What about the angle of P? In other words, what would alpha be equal to then? How would you calculate alpha? Well, we've got the height of the triangle, we've got the base of the triangle, so wouldn't that be an inverse tangent of height, 587.5, over base, 368? Drop into units, because of course they would cancel. So take the inverse tangent of 587.5 over 368. What do you get? Hopefully in degrees. I don't think many of us speak radians very well yet. No, I don't.
57.9.
Thank you. Anyone second that? 57.9 degrees? Almost 58 degrees? I mean, think about it. Does that make sense? Well, it has to be more than 45 degrees, doesn't it? Because it's got more vertical than it has horizontal. So yeah, it's got to be more than 45 degrees. Any questions? Comments? All right.
Just a second to digest